I was at Agenda 2000, and one of the people who was there was Craig Mundy, who is some kind of high mucky-muck at Microsoft. I think Vice President of Consumer Products or something like that. And I hadn't actually met him. I bumped into him at an elevator, and I looked at his badge and said, "Ah, I see you work for Microsoft." And he looked back at me and said, "Oh yeah, and what do you do?" And I thought he seemed just a sort of a tad dismissive. I mean, here's the archetypal, guy in a suit looking at a scruffy hacker. And so I gave him the 1,000-yard stare and said, "I'm your worst nightmare."
For most of its short but colorful history, the computer industry has been dominated by the Windows operating system. But that could soon change, as Windows faces a strong challenge from Linux.
Silicon Valley has long been the place to develop new technology, start new companies, and get really rich. Now the Valley is the front line in a revolution fighting for that most politically incorrect of ideas, individual freedom. Day and night, a loose confederation of hackers and programmers zaps bits and pieces of computer code around the world as it builds the tools to set computer users free. Using open information and the free exchange of technology to achieve its goals, this revolution began in the 1980s with the free software movement and the GNU project, and now is most commonly associated with Linux and the open source movement.
We do have one sector that is taking off today. It is the Linux-related sector. And I thought this might be a good opportunity to say, what is Linux? And I'll answer this question for you. Many of you probably already know, but there are 12 million users out there. A computer operating system developed by hundreds of programmers collaborating on the internet, a challenge to Microsoft Windows NT, very popular for its speed, and so this is what the craze is about.
To kind of explain what Linux is, you have to explain what an operating system is. And the thing about an operating system is that you're never ever supposed to see it, because nobody really uses an operating system. People use programs on their computer, and the only mission in life of an operating system is to help those programs run. So an operating system never does anything on its own. It's only waiting for the programs to ask for certain resources, or ask for a certain file on the disk, or ask for the programs to connect them to the outside world. And then the operating system steps in and tries to make it easy for people to write programs.
Open source is a way for people to collaborate on software without being encumbered by all of the problems of intellectual property, having to negotiate contracts every time you buy a piece of software, have a lot of lawyers involved. In general, we just want to get the software to work, and we want to be able to have people contribute fixes to that, etc. So we sort of sacrifice some of the intellectual property rights and just let the whole world use the software.
Before there could be Linux, there was Richard Stallman and the free software movement.
I mean, think of Richard Stallman as the great philosopher, right? And think of me as the engineer.
Richard Stallman is the founding father of the free software movement. Through his efforts to build the GNU operating system, he created the legal, philosophical, and technological foundation for the free software movement. Without these contributions, it's unlikely that Linux and open source would have evolved into their current forms today.
I joined the MIT Artificial Intelligence Lab in 1971. I joined a thriving community of hackers, people who loved programming, loved exploring what they could do with computers, and they had developed a complete operating system, entirely written there. And I became one of the team that continued to improve the operating system, adding new capabilities. That was my job, and I loved it. We all loved it. That's why we were doing it. And we called our system the incompatible time-sharing system, which is an example of the playful spirit which defines a hacker. Hackers are people who enjoy playful cleverness. Well, it first started going wrong as the outside world started pressuring us to have passwords. We didn't have any passwords on our computer. And the reason was that the hackers who'd originally designed the system realized that passwords were a way that the administrators could control all the users. And they didn't want to build tools, you know, locks and keys for the administrators to control them. So they just didn't do it. They left that out. And we had the philosophy that whoever's sitting at the computer should be able to do whatever he wants, and somebody else who was there yesterday shouldn't be controlling what you do today. When they put passwords onto one of the machines at MIT, I and a bunch of other hackers didn't like it. I decided to try a subversive sort of hack. I figured out how to decode the passwords, so by looking at the database of encoded passwords, I could figure out what each person would actually type to log in. And so I sent messages to people saying, hello, I see that you've chosen the password mumble, or whatever it was. How about if you do as I do? Just type enter for your password. It's much shorter, much easier to type. And of course, with this message, I was implicitly telling them that the security was really just a joke anyway. But in addition, I was letting them in on this hack. And eventually, a fifth of all the users on that computer joined me in using just enter as their passwords.
Where did the ideas that led to what is now called open source, how did that begin? Who began that?
Well, it actually began with the start of computers, because at that time, software was just passed around between people. And I think it was only like in the late 70s, early 80s, that people started really closing up their software and saying, no, you can never get a look at the source code. You can't change this software, even if it's necessary for you to fix it for your own application. And you can actually blame some of that on Microsoft. They were one of the real pioneers of the proprietary software model.
In the mid-1970s, a group of hackers and computer hobbyists in Silicon Valley formed the Homebrew Computer Club. In the club's January 31st, 1976 newsletter, Bill Gates of the recently formed Microsoft wrote an open letter to the community where he made a point-by-point argument for the relatively new concept of proprietary software. Up to that point, the practice of computer users had been to freely pass around software with not much thought given to its ownership. Known as an open letter to hobbyists, Bill Gates writes, "To me, the most critical thing in the hobby market right now is the lack of good software courses, books, and software itself. Without good software and an owner who understands programming, a hobby computer is wasted. Will quality software be written for the hobby market?" Gates goes on to write, "The feedback we have gotten from the hundreds of people who say they are using BASIC has all been positive. Two surprising things are apparent, however. One, most of these users never bought BASIC, and two, the amount of royalties we have received from sales to hobbyists makes the time spent on Altair BASIC worth less than $2 an hour. Why is this? As the majority of hobbyists must be aware, most of you steal your software. Hardware must be paid for, but software is something to share. Who cares if the people who worked on it get paid? Is this fair? One thing you don't do by stealing software is get back at MITS for some problem you may have had. MITS doesn't make money selling software. One thing you do is prevent good software from being written. Who can afford to do professional work for nothing? What hobbyist can put 3-man years into programming, finding all bugs, documenting his product, and distribute it for free? The fact is, no one besides us has invested a lot of money in hobby software. What about the guys who resell Altair BASIC? Aren't they making money on hobby software? Yes, but those who have been reported to us may lose in the end. They are the ones who give hobbyists a bad name and should be kicked out of any club meeting they show up at. I would appreciate letters from anyone who wants to pay up or has a suggestion or comment. Signed, Bill Gates, General Partner, Microsoft."
In the late 70s and early 1980s, Richard Stallman was doing artificial intelligence research and coding at the MIT Artificial Intelligence Lab. Richard had a number of negative experiences during that period which soured him on the whole idea of commercial software.
Such as?
Some code that he wanted to work on and wanted to fix was locked up, and he couldn't get the company that owned the code to let him fix it, even though it would have been to their advantage to do so.
And that put me into a moral dilemma, you see, because to get one of the modern computers of the day, which was the early 80s, you would have to get a proprietary operating system. The developers of those systems didn't share with other people. Instead, they tried to control the users, dominate the users, restrict them, saying, if to get this system, you have to sign a promise you won't share with anybody else. And to me, that was essentially a promise to be a bad person, to betray the rest of the world, cut myself off from society, from the cooperating community. And I had already experienced what happened when other people did that to us, when they refused to share with us because they had signed these contracts. And it hurt the whole lab, kept us from doing useful things before. So I just wasn't going to do that. I felt, this is wrong. I am not going to live this way.
And from experiences like this, he developed a profound hostility to the idea of intellectual property in software. He eventually acted this out by founding the Free Software Foundation.
So I looked for another alternative, and I realized I was an operating system developer. If I were to develop another operating system, and then as the author encourage everyone to share it, say, everyone, you come and get it, use this, form a new community, not only could I give myself a way to keep using computers without betraying other people, but I'd give it to everybody else too. Everybody would have a way out of that moral dilemma. And so I realized this was what I had to do with my life. I actually began the project in January of 1984. That's when I resigned from my job at MIT to start developing the GNU operating system. Now, I should explain that the name GNU is a hack, because it's a recursive acronym. It stands for GNU's not Unix. You see, so the G in GNU stands for GNU. And what the name means is I was developing a system that was like the Unix operating system, but was not the Unix operating system. This was a different system. We would have to write it completely from scratch because Unix was proprietary. We were forbidden to share Unix. We couldn't use Unix. It was useless for a community. So we had to write a replacement for it.
Throughout the 1980s, as Richard Stallman was building the GNU project, computer scientists from the University of California at Berkeley were developing their own free operating system. Known as Berkeley Unix, or BSD, it was based upon the Unix kernel which had been licensed from AT&T. However, due to legal problems with AT&T and fragmentation of the source code, hackers and other non-institutional users were slow to adopt it.
Well, Unix consisted of a large number of separate programs that communicated with each other. So we just had to replace these programs one by one. So what I started doing was writing a replacement for one program, and then another, and then another, and then people started joining me because I published an announcement inviting other people to join me to help write these programs. And by around 1991, we had replaced practically all of them.
What were some of the programs that you...
Well, we had to have a complete system, you need to have a kernel, which is the program that allocates resources to all the other programs. You need a compiler, which translates a program from readable source code that programmers can understand into numbers, mysterious numbers that the computer can actually run. You need other programs that go with the compiler to help do this job. You need a debugger, you need a text editor, you need text formatter, you need mailers, you need lots and lots of things. There are hundreds of programs in a Unix-like operating system.
I saw Stallman's announcement. Actually, I met him in February of 1987. He came to give a 5-day tutorial on Emacs at our company. And during the day, he would explain new ways to think about Emacs and ways to extend and enhance it and to use the Emacs source code for better or worse. But in the evening, he was busily working on this compiler, and he had not yet released it to the public, so he was being a little bit careful about who got to see the source code. But I was very eager, and when he first announced it in June, I downloaded it immediately. I played with it. I got some pointers from him, and when I sent the source code back to him, he was very actually amazed at how quickly I was able to ramp up on his technology.
Whenever we worked on something at Stanford or in the university, we would get, mostly at the time we were working off of machines from Digital Equipment or Sun, mostly Sun. Whenever we would get a Sun machine, the first thing we would do is we would spend literally days downloading GNU free software from the internet, building it and installing it on that Sun machine.
The crucial thing about GNU is that it's free software. Now, free software refers not to price, but to freedom. So think of free speech, not free beer. The freedoms that I'm talking about are the freedoms to make changes if you want to, or hire somebody else to make changes for you if you're using the software for your business, to redistribute copies, to share with other people, and to make improvements and publish them so that other people can get the benefit of them too. Now, those are the freedoms that distinguish free software from non-free software. These are the freedoms that enable people to form a community. If you don't have all these freedoms, you're being divided and dominated by somebody.
My first experience contributing to free software came in late 1989, early 1990. I was working as a graduate student at Stanford University on computer-aided design tools. One of the pieces I needed was a tool called a parser generator. Well, the Free Software Foundation under Richard Stallman had created a great tool called Bison. I needed a tool that worked with C++. Bison worked with C. I modified Bison to create something called Bison++. And it was a tremendous feeling of empowerment to be able to take a piece of software that was available and create what you needed in a very short piece of time by modifying it. I put it back on the internet, and I was amazed at the number of people that picked it up and started using it. In fact, I remember going to job interviews. I at various times considered just going out and getting a job, and I had gone to a job interview, and I was talking with one of the people, and I started asking them about what tools they used, and they said, gee, we use Bison++, and I said, oh, I'm the author of Bison++.
Free software generally does have a copyright, it does have an owner, and it has a license. It is not public domain.
If we put the software in the public domain, somebody else would be able to make a little bit of changes and turn that into a proprietary software package, which means that the users would be running our software, but they wouldn't have freedom to cooperate and share. To prevent that, we use a technique called copyleft. The idea of copyleft is that it's copyright flipped over. And what we do is we say, this software is copyrighted, and we, the authors, give you permission to redistribute copies. So we give you permission to change it. We give you permission to add to it. But when you redistribute it, it has to be under these terms, no more and no less, so that whoever gets it from you also gets the freedom to cooperate with other people if he wants to. And then in this way, everywhere the software goes, the freedom goes too, and it becomes an inalienable right to cooperate with other people and form a community.
And so what is that, the license? What is that?
Well, copyleft being a general idea, in order to use it, you have to have a specific example. And the specific example we use for most GNU software packages is the GNU General Public License, a particular document in legalese which accomplishes this job. A lot of other people use that same license. For example, Linus Torvalds uses that license for Linux as well.
Well, the license I use is the GNU General Public License. That's the one that Richard Stallman wrote, and I think it's a really astounding contribution. It's one of the few software licenses that was written from the standpoint of the community rather than from the standpoint of protecting a company or, as is the case with the MIT and the BSD license, performing the goals of a government grant program. And the GPL is really unique in that it's not just a license, it's a whole philosophy that I think motivated the open source definition. I don't hide that a lot of what I do came from Stallman.
A crucial step in the growth of GNU, Linux, and the free software movement was the creation of businesses based upon the software and philosophy. Ground zero for the beginning of the business phase was the Electronics Research Lab at Stanford University. Known as ERL, the lab was the place where the first GNU and Linux businesses found their inspiration.
So right here is where ERL was. That would have been the entrance over there next to the Electrical Engineering McCullough building. So you walk in, you come in, you walk down the hallway down here, My office would have been about here, and then right across the hall from that was Michael Tiemann's office. Michael Tiemann took and started a company, Cygnus Software, but the idea was to sell consulting and services around the GNU free software. And, well, Michael's done very well with Cygnus. Well, I spent a lot of time working out how we were going to make money, and in the original GNU Manifesto, which is the last chapter of the GNU Emacs manual, Stallman proposed a number of different possible ways to make money.
From the beginning of the free software movement, I've had the idea that there's room in it for business to be done. One of the advantages of free software is that there's a free market for any kind of service or support. So if you are using software in your business and you want good support, you have a choice of people to go to for it. You have a choice of businesses that are in the business of providing you with support. So they're going to have to, in general, give you good support, or you'll go to somebody else. With proprietary software, support is a monopoly. There's one company, typically, that has the source code, and only they can give you support. So typically, you're at the mercy of a monopoly. That's the case, for example, with Microsoft. So no wonder the support is so bad.
The benefits of free software were tremendous, but the cost of supporting it internally made managers very, very nervous. And so the fundamental idea I had was, if we could build a model that could deliver 2 to 4 times of support and hand-holding capability that an internal engineer could provide, and we could do it at 1/2 to 1/4 the cost, that would meet the test of whether or not people would actually buy. And by about the fall of that year, we had all of the things worked out about who we needed on the technical team, what the terms of the sale would be, what the key price points were, and we actually received our incorporation in November of 1989. One of the most difficult things in starting our company was actually finding a name for it. I explained this to one of my friends. We were having difficulty, and he returned an email message that basically just had a bunch of words with the name GNU in it. And Cygnus was the one that looked least obnoxious and least obscene.
I can say very clearly that Cygnus was the first business that specialized in free software. Cygnus supported free software, filled a very essential niche because we had this great software. You could get it for nothing, but you couldn't get support, and they made their money by charging for support.
The GNU project started by building a toolkit of basic development tools such as a C compiler, a debugger, a text editor, and other necessary apparatus. And their intention was eventually to develop a kernel to sit underneath those and be the center of the operating system. By about 1990, they had successfully developed that toolkit, and it was in wide use on a great many variants of Unix, but there was still no free kernel.
The kernel happened to be one of the last things we started to do, and we had started it not long before. And that's when Linus Torvalds came along.
Linus or Linus? What's your preferred pronunciation?
When I speak Swedish, it's Linus. When I speak Finnish, it's Linus. When I speak English, it's Linus. And I really don't care how people pronounce my name. But Linux is always Linux.
He developed a kernel and got it working faster than we got ours working, and got it to work very nicely and solidly. His kernel is called Linux.
The initial goal was my very personal goal, to be able to run a similar environment on my computer that I had grown used to at the university computers. And I could not find anything that suited me for that, right? So having been doing computers for all my life, basically, at that point I just decided that I'll do my own. Most of the inspiration early on came from Sun OS, which was what I was using at the university at the time.
Which university?
University of Helsinki in Finland.
From 1991 to about 1993 was really, I guess, the infancy period of Linux. That was when it was still only alpha or beta quality. It was relatively unstable, although even then it was a good deal more stable than a lot of what are now called production operating systems.
Linus used the traditional tried and true method of writing one program that does the job, and he got it to work quickly, in fact, faster than I would have thought was possible.
The term for it is monolithic, which means that basically the OS itself is one entity, indivisible, while in a microkernel, the operating system kernel is actually just a collection of servers that do different things, and then they have a common protocol for doing communication between themselves.
So why is it that if the GNU project had so much lead time, so to speak, doing this, why is it that he was able to kind of come in at the tail end, so to speak?
Well, we actually started the GNU herd not long before he started Linux. And as it happened, though, we chose a design that's a very advanced design in terms of the power it gives you, but also turns out to be very hard to debug. We decided to divide up the kernel, which traditionally had been one program, to divide it up into a lot of smaller programs that would send messages to each other asynchronously to communicate. And the problem is that that style of programming has a great deal of potential for bugs, which are often very hard to figure out because they depend on, does this program send this message before or after this one sends that message? And the result was, it took us years to get the thing to work.
What is Linux's relationship to the GNU project?
Well, there's relationships to GNU on kind of multiple levels. One is just a philosophical level of thinking that making your source open is a good idea.
When Linus developed the kernel, he wasn't doing it for the GNU project, he did it independently. And he released it independently, and we didn't know about it, but some of the people who did know about it decided to look for what else they could find to put together with that kernel to make a whole system. And they looked around, and lo and behold, everything they needed was already available. What good fortune, they thought, but actually there was no chance about it. They had found all the pieces of the GNU system, which was missing just the kernel. So when they put all that together, really they were fitting Linux into the gap in the GNU system, but they didn't know that.
There's a lot of these programs done by the Free Software Foundation and done by other people like Linux, and there's a symbiosis between Linux and the programs, so that the programs run on Linux and at the same time, and they take advantage of Linux as a platform, while Linux takes advantage of the programs by just being able to use them.
What programs?
For the main one is actually the GNU C compiler, which without a C compiler it would not have been possible to make Linux or most of the open programs available. Linux uses the GPL, and I agree with the kind of philosophy behind the GPL. That said, the GPL itself is not a very pretty document, which is probably just because no lawyers can ever be very pretty.
Well, I'd been playing around with Linux for actually late 92, early 93 for about a year before I decided it was to the point where it actually had everything that I needed to really replace the Sun workstation. And I was looking for a way to have a Unix workstation at home. At the time, we used Sun Spark stations in the office at Stanford. Those machines cost us about $7,000. Now, I desperately wanted a Unix machine at home. There's always this thought you get as a graduate student, gee, if I could work at home, then I would be so much more productive. I would graduate sooner because I would finish my thesis sooner. Well, is it true? Well, you can judge, you know. Most people end up spending a lot of their time becoming more productive so that if they ever actually worked on their thesis, they'd finish it in a day. It takes a while sometimes. So I decided I wanted a Unix machine at home. And I went out there and was able to use Linux together with a PC. For about $2,000, I put together a system that was 1.5 to 2 times faster than that $7,000 Sun Spark station. That was absolutely amazing. I had 1.5 to 2 times the speed at 1/3 to 1/4 the price. Light bulbs went off. I knew there was an opportunity here. This was a chance to really do something better than what Sun has done around open source. and Linux?
I called it Linux originally as a working name, and that was just because Linus, and the X has to be there. It's Unix. I mean, it's like a law. And what happened was that I initially thought that I can't call it Linux publicly because it's just too egotistical. And that was before I had a big ego, right?
They thought they were taking a whole bunch of components and putting them around Linux. So they ended up calling the whole thing a Linux system, and somehow that term caught on. And the result is there are now 10 million people using this variant of the GNU system, the GNU/Linux operating system, and most of them don't know it.
Some people advocate that it be described as GNU/Linux. I mean, what's your thought on that? Is that justified, or?
Well, I think it's justified, but it's justified if you actually make a GNU distribution of Linux. The same way that I think that Red Hat Linux is fine, or SUSE Linux, or Debian Linux. Because if you actually make your own distribution of Linux, you get to name the thing. But calling Linux in general GNU Linux, I think, is just ridiculous.
I got involved in fall '93 because I was sent a copy of the first CD-ROM commercial Linux distribution, which was called Yggdrasil. It was produced by Adam Richter. And I got a copy because I had been myself writing free software for a long time, since the early '80s. I was actually one of the early GNU contributors myself. And I was absolutely astonished. I was completely astonished because I'd been a software engineer for nearly 15 years at that point, and according to all the rules I knew about controlling complexity, keeping your project groups small, having closely managed objectives, Linux should have been a disaster, and it wasn't. Instead, it was something wonderful, and I was determined to figure out how they were getting away with that.
In order for Linux to grow beyond the world of the computer programmer, it needed a use, an application that made it a must-have technology. That threshold was crossed with the development of a program that made complex websites possible. That program is the Apache web server.
The killer app of Linux was undoubtedly the Apache web server. If you look at the history of Linux, the adoption curve of Linux and the adoption curve of the internet exactly track each other. 1993, which was when the Apache web server project really got started, was also the beginnings of the popular ISP explosion, when the internet first became a mass market commodity and the idea of web-based electronic commerce and mass communication became real.
I think it was one of the first applications that caused people to go, wow, if I install Linux, I get some tangible benefit from doing so, right? I mean, clearly there were a lot of interesting applications on Linux at the time, this being maybe 2 or 3 years ago when this thing really started to take off. But there wasn't a driving, you could almost say business case for someone to use Linux versus using NT until, I think, Apache. And a lot of the things that plugged into Apache and enhanced Apache. I mean, when you went to go out and build a server farm, it was much more cost effective, real dollar terms, to build it on Linux and Apache than it was to build it on IIS and NT, even if it meant that you had to spend a little bit of money to train your staff to learn how to use that or to find people who were knowledgeable. But the good news was that that knowledge wasn't very expensive because there are all these college students out there who had been using Linux for a long time and were very familiar with it.
If you look at the trend curves in web servers, Apache has steadily been gaining in market share ever since. It's up to something like 66% now. It's steadily clobbered all of the closed source competition. And that's because it's more reliable, it's more flexible, it's more extensible. It does what webmasters actually need. And the combination of Apache and Linux found its way into a great many commercial shops.
Essentially, Apache became the application that motivated internet service providers and e-commerce companies to choose Linux over Microsoft's Windows.
It would probably run best on Linux and on FreeBSD. And the reason is the communities around those operating systems are also the communities that contribute the most back to Apache, right? And they were also the operating systems that internet service providers started using very heavily as well. And internet service providers really liked Apache because it allowed them to do a lot of different things that some of the commercial web servers didn't, such as the ability to host more than one website on a single box, which clearly if you're an ISP and you have 40,000 users and they all want their own website is going to be pretty important to you.
One of the key factors in the growth of Linux was the creation of companies that specialized in the distribution and support of the operating system itself. Among these companies, Red Hat Software is the best known.
Red Hat started as a product of Mark Ewing. While he was working at IBM, he wanted a little better Linux distribution. He started playing around. Found out he spent more time maintaining his Linux distribution than he did working on his new project. So he sort of started the distribution itself. He met up with Bob Young, who at the time was running a company called ACC Bookstore, which was a mail-order PC Unix catalog. And Bob kind of knew he wanted something, more his own to market rather than reselling other people's products, and he was fairly good at marketing, and Mark knew he needed some marketing help because he was fairly good at the technical parts, so they kind of got together. I started working with Red Hat in May of 1995, basically right out of NC State, along with Eric Trowan, who me and him combined make up employees number 4 and 5. And we actually reported to work at an apartment that Mark Ewing used to live in. We took it over as kind of the development part of Red Hat Software, and stayed that way till about November of 1995 when a toilet we had in the apartment kind of exploded, flooded our downstairs neighbor, and she got a little upset, and the apartment folks found out we were running a business there instead of actually living there at the same time, so they decided to throw us out. So at that point we had about a week to go find our first office, which we did, and get ourselves moved in a hurry. So.
We started going in, again, 95 or so to the venture capital firms, saying, there's something happening here. There's a great business opportunity to build the next Sun for open source. Well, the venture capitalists looked at this and said, gee, you're selling systems, the software's free, this is kind of scary. We're not sure that we want to put money in. And by the way, we funded other systems companies, and it hasn't really panned out. We're scared.
I came to the U.S. about 3 years ago, and the reason really was that I'd been spending like 6 or 7 years at Helsinki University and decided that it was time to see the real world and not just university life. Especially this area had a lot of the most interesting work being done. So I just decided that let's try to move halfway across the world and give this a try, and it's turned out pretty well.
Do you see this as temporary or long-term?
Well, we saw it as temporary at first, and I think it's certainly looking like it's turning long-term. Our youngest daughter is both a US and a Finnish citizen because she was born here, and the older one is speaking both Swedish and English, so.
The next major event was one that I had a direct hand in. I wrote a paper called The Cathedral and the Bazaar, which was my observations, my anthropological analysis of what it was that made the open source world work. We didn't call it that then. We're still using the term free software primarily. So it was my observation of what made the free software world work and why we were able to produce extremely high quality software in spite of constantly violating all of the standard rules of software engineering. In that paper, I was setting up a contrast between two different styles of development, two opposed styles of development. One, which is the conventional closed development style, which I called the cathedral style. In that one, you have tight specification of objectives, small project groups which are run in a fairly hierarchical, authoritarian manner, and you have long release intervals. On the other hand, what I identified as happening in the Linux world was a much more peer-to-peer, decentralized market or bazaar-like style in which you have very short release intervals and constant solicitation of feedback from people who are formally outside the project, a very intense peer review process. And the startling thing was that the more I looked at this, the more it seemed that trading away all the supposed advantages of conventional closed development for that one single advantage of massive independent peer review actually seemed to win, actually seemed to get you good results.
The reason Netscape is important is that they were the first large company to participate in open source. We had Cygnus providing support, but we didn't really have much business. And Netscape went to open source essentially as a way to fight Microsoft, which was giving away Internet Explorer, but not letting anyone else have the source code, not letting companies collaborate.
Working as part of the sales force, I got a good idea of why people bought our software and what it took to make our software successful in the marketplace against competitive products. However, the problem we were seeing is that as time went on, our software was being competed against by other people's software, particularly Microsoft's. And as time went on, the price of our software had to drop because other people were giving their software away at no charge or at little charge.
No, the real problem was that they feared that Microsoft would achieve a monopoly lock on the browser market, and they would then use that monopoly lock to pervert, actually, the HTTP and HTML standards that the web depends on. And once they had turned those standards into lock-in devices, they could then use that control to drive Netscape out of the server market, which is where it was making its real money.
My concern was that as time went on, Netscape's business would be threatened by the fact that we didn't have enough people to do all the things we needed to do as a company in order to keep our software viable in the marketplace.
The Netscape release happened in early 1998, and I was told later, I had no idea at the time, that it came about as a direct result of the right people having read The Cathedral and the Bazaar.
The Cathedral and the Bazaar, the paper by Eric Raymond, was a significant influence on Netscape's decision to release source code.
Came as a complete shock to me. I wasn't really ready for the thought that I was changing the world, even by accident.
However, it was not by any means the only influence on that decision, and not necessarily the most important one when all is said and done. As I said, Netscape had already been talking about releasing source code for quite some time before anybody had ever heard of Eric's paper.
Linux